everyone seeing the screen?
Yes, I'm seeing.
Yes, great. So, good day, everyone, and welcome to Women in Data Science Trinidad and Tobago's workshop series. This is our Data to Dashboards Upskill workshop series for 2026. I am Dr. Leticia Addison. I'm the WiDS Trinidad and Tobago ambassador, and I will be walking you through today's proceedings with some of our mentors and volunteers from the team. Today's workshop is going to look at a hands-on introduction to Streamlit. But before we get started, we just want to think about, for those of you who are new, what is Women in Data Science? Women in Data Science is a global organization which elevates women globally, and we attempt to celebrate, inspire, educate, and support persons through extensive programming, webinars, workshops, conferences, datathons, podcasts, WIDS Next Gen, and of course, we have these little webinars and of course forums, both in person and online, that we have interest from the public to join and interest from the community. Also wanting you to know that this movement started in 2015 at Stanford University and has grown tremendously across the globe with more than 200 regional events and more than 100,000, probably greater than that even now, in terms of participants. Now, a lot of you who may be joining would be familiar with the WIDS Datathon. There is a global Datathon challenge that happens every year. And this year, we also have a 2026 Global Datathon challenge, which involves persons who would like to understand how to use data science and machine learning in a social impact challenge to be able to really predict and provide real-world insights. Now, for the purposes of our team, we have post webinars, workshops, and regional events which support the Datathon and also beyond the Datathon, for instance, in terms of upskill workshops as you are in today. Now, we host independent events to encourage and support data literacy at all levels. For those of you who are here, you would have signed up for this workshop today. This is part of a two-part workshop series on data to dashboards. And this series is really a sequence designed to help participants transform raw data into meaningful interactive dashboards. If you would like more information on our events that we have hosted in the past, since 2022 until present, you can feel free to go to our website, www.widstt.com, for more information. And of course, I'll have some of my volunteers in the chat who would also provide a link for you as we go along. Now, we will hear a little bit more about data science today in terms of this particular workshop with respect to using Streamlit. For those of you who are now joining who may be a beginner and trying to understand what it is, I've just put one snapshot slide here for you to see in terms of data science, really in terms of the origins being in math, statistics, and computer science. And it includes machine learning concepts, artificial intelligence, and Internet of Things. And really what we're trying to do is create meaningful insights and actions out of our data, including looking at data mining, cleansing, analysis, visualization, and of course, actionable insights. So we have a group of mentors today. We have two main mentors who will be going through the workshop itself today. That is Mr. Nicholas Smith. I'm going to introduce them in a second, so they'll introduce themselves, and Ms. Leslie Ann Girowan. And if you want to read more about them, you can also visit our team link, with tt.com/about-us/our-team. It will be in the About Us section of the widstt.com page, so you can read a little bit more about them. So I will stop sharing and I will invite our speakers to give a little bit about themselves. So let us start off with Nicholas. Nicholas, can you give us a little bit of context into who you are and what brought you here in terms of your background?
Sure, no problem. Are you able to hear me?
Yes, we can.
Okay, great. So my name is Nicholas Smith. My background is mainly in computer science, but from UWI, this is where I got my bachelor's in computer science. While I was doing this, I decided to teach myself about data science, machine learning, and use online resources and courses to get better at it. Currently, I'm a part-time tutor for some courses at the Department of Computing and Information Technology at UWI. I'm also a volunteer mentor here at WiDS TT. And some background on what I have built. I would have built some dashboards and RAG systems using the same Streamlit you'll learn about today, Power BI, Tableau, LangChain, a bunch of other technologies. And I also work in full stack, desktop application, and mobile application as well. I actively practice and favor deep structural technical explanations, and I am interested in philosophy, cognitive psychology, chess, movies, languages, sociology, anthropology, and system architecture. And that's just a brief about me. Think I can move on to Leslie.
Yep. Leslie-Ann, take the floor.
Hi, morning, everyone. I'm Leslie. I went to the University of Waterloo to do computer science, and I did it for 3 years and decided that's not where I wanted to stay. I love computer science, but I was pulled in like different directions and graduated with mathematical sciences. So that's kind of like an interdisciplinary within math. And I did the kind of things like touched on statistics and combinatorics and optimization, as well as pure math. And that's what kind of like prepared me for data science, even though it would be a decade or so later. And made it very easy to get back in. Very easy, what am I saying? Interesting and a smoother transition, I should say. I also took a master's in small and medium enterprise management when running my bean to bar chocolate business. And I also taught English in Japan and math and IT in Trinidad. So I've been an educator for, I'd say, 10 years, a bit more, and doing things like this with the women in data science is really something I love doing, as I'm passionate about helping women and girls see themselves in STEAM careers, not just STEM, but the A for arts altogether is something I'm very passionate about. And led me to start my own NPO, thanks to Dr. Edison's example, called the Argante Foundation. And I'm happy to be able to continue the work we do here in other areas as well. Thanks.
Thanks so much for that, Leslie-Ann, and thanks, Nicholas, as well. So the two of you are going to be taking over the session today, so I will pass the floor over to you to begin today's workshop.
Okay, I'm sharing my screen here. Can I get a confirmation that it is being seen?
Confirmed.
Thank you. So I'll just get started right away. Welcome again to our Data to Dashboards Upskill workshop using Streamlit. This is the first of 2 workshops, as you were told. And my aim today is to just set Nick up for his action-packed session. We are your mentors today. Nicholas is our data cowboy, and I'm his data fairy, in that all those exciting things you heard him talking about him building, I just watch them and say, whoa, that's cool. So yes, I flip from one thing to the next, and my whole thing is about make it pretty, make it fast. And that's why I'm really excited to see what Nick is going to teach us today, because that's exactly what Streamlit is about. So this is the agenda for today. So here we are. This is my section here. I'm going to tell you about data science, data, and dashboards. And I'm going to keep to this 30 minutes, come hell or high water, so that we can get straight into these live demos with Google Colab and Streamlit with Nick. And then we'll wrap up at the end, and questions will be answered. And during that time, I talk pretty fast, and I will try to slow it down, but today I really want to get into the live demo with Nick. So feel free to raise your hand at any time. I'm not going to answer it, but you can feel free. Just kidding. One of our lovely moderators will bring that to our attention, and someone will answer. So let's get started. By the end of this workshop, we'd like to know how to load data, identify missing values, understand the data distributions, and spot patterns. We're going to create new features, which I'll tell you about later, and handle those those bits of missing data and prepare that data for modeling. And what we're all here for, to build the Streamlit dashboard with some interactive visualizations, and it's going to be very exciting. So this is the order of events for here. We have our what is data science, what is Kaggle, how we're gonna get the data from Kaggle and to use today. And I'm going to tell you about that data. And then I'm just going to introduce what we're all here for, the Streamlit dashboard and why we use it. So first of all, what is data science? Dr. Addison gave you a sneak peek. So at the tip of the data science iceberg, we have visible results, which are the reports, the dashboards, those the statements like customer churn is expected to increase by 10%. Those are the insights that we're getting from our predictive model. And that's what the boss, the CEO, that's what they might hear, right? But below the surface, we have a lot of stuff going on. You heard about the data cleaning and our exploring our data. I put in data collection as well because in a perfect world, someone would just send us the data file and we can just start. But more often than not, we are responsible as data scientists for getting the data, pulling it from wherever it's living, and starting with it from there. So data collection, we also have to include in that massive iceberg there. Also, under beneath the surface is the meat of the thing, which is our machine learning and our statistical models that are what produces our predictive and prescriptive analysis. Predictive meaning we're forecasting the future. Prescriptive is that we're going one step further and taking action on what we think might happen in the future. So given that Dr. Addison described data science in this way, here's the simplest version I can think of. It's a broad field that involves extracting insights from data. What do you think is machine learning? It's building those algorithms that learn from the data to make those predictions or decisions. So you can think of machine learning as a tool for doing that prediction and modeling. And modeling, the predictive modeling and pattern recognition. Sorry for that. So we'd like to know what's the relationship between these different concepts. So how is machine learning related to data science and AI? So in general, we have artificial intelligence, creating smart machines to mimic human behavior. So within that, we have, as a subset of AI, we have machine learning, and that's building our models and training our data to make our predictions. So we also have deep learning within that, a class of machine learning. And you see data science overlaps a bit, but not all data science is machine learning or artificial intelligence. So we want to go a little bit deep into that. So based on what you might have heard, Dr. Addison say in her slide, and what I just you might have seen in the previous slide, if we look under the hood to see what machine learning really is, you might, if you've seen this meme already, you might know the answer. But in the chat, can you give me your guesses? Who do you think is really under there? Feel free to type in the chat. Okay, people have no idea. Okay, I'll tell you, it is statistics. Thank you very much, one person who guessed. So yeah, statistics is really the main driving force under the machine learning. That's what you need to know. And continuing on our main journey, perhaps you've seen this one. We have this crack in the wall at statistics, right? And we just think, oh, statistics is math, right? But recently, when we frame it as machine learning, it's a big buzzword. And but really under the hood, if you look, it's really just statistics. With the attention that we're getting by framing a statistic this way as machine learning, we also have people looking in, and suddenly kind of using those terms, machine learning and artificial intelligence, interchangeably. And from what you know now, it's not exactly right, not exactly wrong, but machine learning is part of artificial intelligence, but shouldn't be used as exactly the same thing, you know? So that being said, true or false? Is statistics all you need to know for data science? True or false? Please type that in the chat. Thank you very much. So, I don't know if Dr. Harrison would disagree, but statistics is a huge part and puts you ahead of a lot of people, but there are a couple more things that you need to know. So you should know some technical skills like some Python, some kind of programming language. Python is very, probably the most popular for data scientists. And is a very low barrier to entry, and you have access to all these amazing free libraries, like what we're learning today, Streamlit. And if you're coming from a statistic background, you might be more familiar with R, though, and that's good to do as well. If you have questions about that, I'm sure Dr. Hudson can help you there. And also SQL is also recommended for data scientists to be aware of, because that's what we would use in getting our data out of a big data warehouse or something like that, using BigQuery or something like that. Machine learning, which we talked about before, and we'll talk about again, and our AI techniques. So based on this slide here, I put a little answer over here for this one. The key skills for data science, right? What goes right here? If we have data science being a mix, combination of computer science or IT, math and statistics, together they're machine learning. If we just have traditional research, we use statistics and what's. You can tell me in the chat. The clues is that the
You want to
answers
give them
on.
some clues?
Yeah, the clues that they're on. The answers on the screen already, and it's the title of the slide. And going back one at the bottom here, you can see that if we have we know statistics, we know Python, we know modeling, and we add something called domain knowledge. That's everything that comes together to make up data science. So that's the answer, domain knowledge. So industry-specific expertise to translate findings into actionable business value. So in this case, this could be, for example, me going in to do a data science project, and my background is like in cocoa. Or so if I have data or on some cocoa beans and their fat, like I would know that these dry beans would be needed to be below 7% moisture, something like that. That would be my domain knowledge. That being said, you don't always have to have that. You don't have to be the person with that domain knowledge. You could be in your company and referring to the domain the industry specialists to get their insight, and that's where that domain knowledge comes from. So altogether, you need these technical, analytical, and domain knowledge skills to be a good data scientist. So why data science matters? Can you tell me in the chat, what is a zettabyte? How many gigabytes in a zettabyte? Does anybody know? or like how many gigabytes? Yeah. How many I'm confusing myself, so thanks for giving us a try in the chat. That's 1 trillion gigabytes, chat. That's a lot. So 181 zettabytes. Do you know the relevance of this number? Last year, people would have been talking about this a lot. Thanks, chat. Yes, so that's how much they estimated the amount of data created, captured, copied, and consumed worldwide by the end of 2025. That's a lot, man. Especially since in the last millennia, all the human's knowledge could have been stored in something like, I think, 5 terabytes or something like that, something ridiculous like that. As data grows exponentially, the demand for data professionals is expected to grow by 36% by 2033. So yeah, data science matters. So where can you start your data science journey? There's a place called Kaggle where it all comes together. In the chat, you can let us know if you know about Kaggle, if you heard about Kaggle. You can just let us know there. And in the meantime, I'm going to tell you about why is Kaggle. Kaggle was to answer the need for beginners to get practice with data in the real world, because it's hard to get data, people to give up the data or to give you access to data, and they need data that's just clean enough so that they can start a place where you can just go and get your data set, get access to data sets, click on it, and immediately have a notebook loaded up for you, a community who is very, very helpful and just making a zero friction, giving you zero friction access to just start doing data science. It's easier to see than to explain. So if you haven't done it already, in your resources, you should have seen the link, kaggle.com, to go ahead and register for an account. Registering with Google, if you have a Gmail, I think is the easiest, fastest way. And once you go there, you'll get to see on your side panel all these nice things you can do. So I recommend checking out the Learn section, and you'll get all these free courses, things that people pay money for online, free nice courses right here that are connected to notebooks. You're able to try them out live. And beyond that, we are able to access data. So can you guess what data we will be using today? I gave you so many hints in the background. If you want to put that in the chat, what data set do you think we're starting with today, guys? Yep, you're thinking it. You just want to type it. I'm sure the answer is we're talking about the Titanic. So the Titanic data set is the first data set that people encounter on Kaggle, as it's just the right amount of complexity, and it's a topic that everybody knows about. So just to get an idea, when you click or to search Titanic on the Kaggle website, you'll get a page like this, and you'll see a bunch of tabs at the top. And just to get us started, we're going to watch this very nice video right here. Give me a second to get it started.
Have you ever thought about...
Sorry about that. Give me 1 second. There you go. Then just give me a notification if you can't hear, right?
Have you ever thought about maybe entering a Kaggle competition, but you didn't really know where to start, or you felt a little nervous, you went to the site and there's so many things and it was very overwhelming? Don't worry, I've got you covered. Today I'm going to talk about how to get started in a machine learning competition on Kaggle, specifically the Titanic machine learning competition, which we've designed to be the best possible starting place for you. So today I'm going to talk about why to do machine learning competitions, also how, but mostly why, what this specific competition is about, what should you do first, so you've entered, what next, what happens, and then the thing that everybody wants to know, how can you improve your score once you started, climbing up the leaderboard? How can you keep going up it? So why should you compete in this competition? In general, machine learning competitions are a really nice way to play with different techniques and methods where all of the hard and kind of boring work about data science has already been done for you. So the data has been clean, somebody's developed the metric, there's a really clear problem, there's a nice description of everything that's in the data, so you don't have to figure that out yourself. And you can just try different methods and see what works. It's also a really nice way to familiarize yourself with Kaggle and the platform and everything that's on Kaggle. So of course we have competitions, but in the course of the competition you might want to use some different data sets, and you might look through Kaggle's data sets. You can actually write and run your code directly on Kaggle using Kaggle notebooks and then submit from one of your notebooks. We have a video on how to do that. And even if you never do another Kaggle competition as long as you live, it's a really nice way to also start interacting with the community, make some friends. Everybody in the forums is just starting out. We've designed this to be specifically for new Kagglers. So it's a really nice place to ask some questions, maybe answer some questions, and become a part of the Kaggle community. And just so you know, in case you, again, really aren't interested in competitions, the leaderboard is actually cleared every 3 months, so if you're playing around, you don't get a great score, that's fine. It'll disappear. No harm, no foul. All right, let's dive into the challenge. So the Titanic was a passenger ship that very famously and tragically sunk on its maiden voyage, and the majority of people who were on board the boat died. So the thing that we want you to figure out is how to build a model to help predict what factors might have led to somebody surviving or not. So we'll give you information on each of the passengers. For some of them, we will tell you whether or not they perished in the sinking or not, so that you can use that information to train your model. And then for some of the other passengers, we won't. And your job is to try and guess for those passengers that we haven't told you about whether they survived or not. So how do you start? The first thing you need to do is accept the rules and join the competition. From there, you need to get the data. So the data is going to be under the data tab on the competition page, which is the same place you went to join the competition in the first place. And it's going to be broken into 2 files. One is the training data that I mentioned that has all of the different information and features, and also information on whether or not the passenger died. So you're going to use that for your training and your evaluation and your cross-validation. And then the second data set doesn't have any labels, and that's the data set that you're going to send your predictions back for, and that's what you'll be not really graded on, but evaluated on to determine your leaderboard position. Once you have the data, the next step is to really understand the problem, spend some time learning about the Titanic. It's really well documented. Maybe you take a movie break and watch the movie Titanic just to refresh your memory about what the situation of the problem is. And then do some exploratory data analysis. Are there missing values? Are there skewed fields? How are you going to deal with these things? So really get to know and understand the data set. And then start your modeling. So training models, tuning them, changing the hyperparameters to try and get better results for your models, and then ensembling the models, taking your models and putting them together to get your first predictions, and then upload those predictions and you'll get a score. You're on the leaderboard. You're already starting on your journey. And our recommendation is to start with Alexis's step-by-step tutorial. So Alexis is fantastic. She's an amazing teacher. And this tutorial will help you walk through step-by-step, answering your questions, and help you get started in a really nice, simple way.
All right. So you can watch the rest of that video there in the resources. Okay, and so what we have here is let me just move this out of the way. Give me a second. Right, so we have the date. So when you go on this the Kaggle page, you will see these tabs on top here. You click on data, right? To get the data, you scroll down to this section. It'll say gender submission.csv. that's comma separated values. And that's the first of 3 files in this set here. So you can just click download all, because today we'll be downloading it to use for our Streamlit dashboard. But usually you don't have to download anything. You can work everything from Kaggle. Okay. So I want to tell you a little bit of that same data that you're going to get there. I'm just going to tell you a little bit about the variables that you would see in there. So if you click on something called a data dictionary when you're looking around in that tab for data, you'll get the names of all the variables. You'll see something called survival, which will be the main variable that we're interested in. It'll be a 0 for no and a 1 for yes, meaning that each participant, you'll have a number indicating whether they survived or not. We'll have information about their gender, their a ticket number, how much the passenger paid, and their cabin numbers. Then we'll have a variable called P class, which is like the first class ticket, second class, third class. And this is interesting for data scientists as a proxy to understand something about their socioeconomic status or like make some assumptions. So first maybe like the upper class, third might be the lower class, that kind of thing. We'd have some ages of each of the passengers. And if they're like babies, they might have a fractional age. And if they had to estimate the age, it'll be in the form of something 0.5. We have a variable called sib_, which is the number of siblings or spouses, the spouse on board. So your brother, sister, step siblings, husband and wife. There's a situation with the mistresses and fiancés on board, so the side pieces were not acknowledged. Parents and children, the number of parents or children that the passenger had. So in the case where children are traveling with a nanny, you'll see that variable equal to 0. Where nanny only, sorry. So the nice thing about when you click on one of these files on Kaggle is that you immediately can get a little an overview of each of the variables, what they look like, and then this nice little a preview of what the distributions look like. You expect to see a uniform distribution for the passenger ID because it should be just one of each. And then like the survived or not survived would just be 2 values. And yeah, off the top of that here, we already can see that there were a lot more males than females. So that's something that's very useful for a nice feature of Kaggle. The last variable is something called embarked, and that takes the form of C, Q, and S. And it tells us where that passenger got on board. And I put this little map here for you. You can see these are the different places that they could have embarked from and carried on to their journey. This is where they're trying to go, and this is where the unfortunate sinking occurred. So you heard it about twice already in this presentation, but just so I know that you know, and we know that we all know, what does EDA stand for? Can you type that in the chat for me? WiDS members, you can do it too. Here's some hints. Let me give you some multiple choice.
I see we have someone got it the first try.
Oh, thank you very much.
Congratulations to Kayla.
Oh, I was going to give you some other options like this. Everyday agony when the data won't play itself. Eating doubles always. I heard that's a thing. I don't know. Even data apologizes when you have too many outliers. But the answer was exploratory data analysis, which is the official fancy way of saying I'm looking at the data right now. And that's what it stands for. So just to remind you, when you're talking about the different categories or types of variables, right? In data science, we tend to refer to them as features at some point. And just so you don't get confused. In the same way we talk about like we can have categorical, numerical, time series, and kind of textual type things. We have variables that are dependent on time, some that are not, some are discrete, some are continuous. And in the same way, reason I'm talking about this is that each type might have different tips and tricks for dealing with them and making your model work out better. So that's why we have a thing that we do called feature engineering. After we do our EDA and we look around, we get a feeling of what's going on, we can do something that is very essentially selecting or creating the right features from existing data. Based on what we have in front of us, we might make different choices. Like if we have the location given as in the names of countries, it might be better for the model to, when you're feeding it in, to give the column like give numbers for each, like USA equals 1, Canada equals 2. The model might be prefer being fed those numbers instead of these country names. So that's just a random example. There's many different types. There's about, well, 5 main ones. Types of feature engineering, feature creation. Maybe we'll take a couple features and combine them in some way, maybe multiply them, divide them, something like that, to create a new feature that will tell us something more useful about the data, and something that's based on, maybe we asked an expert and they told us, oh, well, it's less useful to, know how much a person traveled per month. What we'd really like to know is how much, I would say average travel, or maybe they don't drive every day, maybe, average per day, something like that. So we might want to transform the data some way using the encoding I told you before, with putting numbers to represent different textual things. We might want to extract features. Some of the features may not be useful for what we're trying to do, and actually be slowing us down and lowering our accuracy. We might want to select some features to see if they work, something, and see if they give a better prediction or something like that. Or we might want to scale our features in case maybe one of our features is kind of stealing the show and overwhelmingly influencing the prediction in a negative way. So in general, I just want to tell you that the reason why we do why do we engineer features? It's really just we care about the model performance. We want to have better and more accurate predictions. We want it to perform better on new data. That's what something called overfitting is something we're trying to avoid. Like if you study for your CXC by only doing one past paper, you become really good at that past paper, but when you see new data, you're in trouble. So also, if we choose features well, we can understand more about how the model makes its predictions, and that's boosting interpretability. And saving time and resources is really a major goal, because it speeds up our model's training and prediction processes. So on to what we're going to create today. What is Streamlit and how to build a dashboard with it? The goal is to go from the data we just talked about here. Here you can see the variables up there. I don't want to look at this anymore. It would be great to go from that to this. Oh, this is so pretty. I'll be able to click on all these things and then see these things change. So Nick built this, and I would like to know how to build it too, but I'm very lazy and I do not know anything. Well, not anymore. I did HTML and JavaScript maybe 20 years ago, and I am not willing to learn it again. So what can we do? Let's find out.
Come on, you've been there, right? You spend hours, maybe days, cleaning data, running your models, and you finally create that one perfect, amazing graph in your Python notebook. But then, what do you do with it? It's just kind of stuck there. You end up sending screenshots or, God forbid, the whole notebook file. So how do you free it? How do you turn that static picture into a real live web app that people can actually use? Well, to see how we get out of this mess, let's jump into a story. It's a classic tale, really. It's got data, it's got distress, and it's got a deadline that is way, way too tight. All right, let's meet our heroes for today. So, on one side, you've got Leslie. She's a super smart analyst. She's found something huge in the data, but she's got just 20 minutes to get it onto a web page for her boss. And on the other side, that's data cowboy Nick. Just look at him. Cool, calm, collected. He knows something Leslie doesn't. And here it is, that moment of pure dread that every data person feels. Leslie's question hits on the dreaded trio: HTML, CSS, JavaScript. I mean, learning just one of those is a huge deal, let alone all three. That's a mountain to climb, right? It's usually where a great idea just dies. Okay, so let's break this down. The old way, man, it's a journey. You've got to build a front end, then a back end, then somehow wire them all together. You're talking days, maybe weeks of work. But then you've got the Streamlit way, and the answer is just Python. That's it, for everything. And suddenly, days of work becomes minutes of work. So you're probably thinking, how is that even possible? Well, this is where our man, Data Cowboy Nick, tips his hat and pulls out his secret weapon. Let's watch as a simple Python script magically turns into a full-on website. And that secret weapon is Streamlit. Now, here's the key thing to get. It's a Python library. This isn't some brand new, complicated framework you have to spend months learning. Nope, it's just another tool you pip install and add to the Python you already know and love. So Nick tells Leslie just write this one line of code. I mean, look at it. It's practically plain English. Stis is just short for Streamlit. You say .title and then you write your title in quotes. It's like you're just telling Python what you want. And boom, instantly, that one line of Python, it just created a web page with a perfectly formatted title. You didn't have to touch any HTML or CSS. It just happened. That's the first bit of magic right there. All right, a title is cool, but what about the main event, the graph itself? Well, you guessed it, the command is just as simple. It's st.write, and then you pop in the name of the variable that's holding your graph. You're literally just telling Streamlit, hey, write this graph to the screen. And there it is. With just that one extra line, her entire beautiful, complex data visualization is now live on the web page. Think about that. 2 lines of code. And Leslie's biggest problem, that trapped graph, is totally solved. It's free. And Leslie's reaction? Yeah, that's pretty much what everyone thinks the first time they see this. It's that, wait, what? Moment. Because this isn't a picture of a web page. It's a real live website, born from just 2 lines of Python. The feeling is just pure disbelief. But hold on, Nick's not done showing off just yet. Because a static website is great, but an interactive one, that's a whole other level. And this is the part that usually gets super, super complicated. So Nick tells her to add this one little line. And again, just look at how readable that is. You're telling Streamlit you want a slider, you give it a label, a starting number, and an ending number. That's it. You're just asking for it. And what happens? Bam, a perfect, working, interactive slider pops right into the app. You know, normally, this kind of thing would take a whole bunch of ugly HTML and complicated JavaScript to get working. Here, it's one line of Python. Leslie's reaction is just perfect. Straight up witchcraft. Because it really, really feels like it. You've just gone from showing static data to building a real tool that people can actually play with, and you still haven't written a single line of code that wasn't Python. Okay, so what's really going on here? What's the secret sauce that makes all this possible? How does Streamlit actually pull off this so-called witchcraft? Well, here's the secret, and it's so simple. It's this: stay in Python. That's the whole idea. You do what you do best, write Python. Streamlit takes care of all the other junk, all the heavy lifting of web development behind the scenes for you. You just focus on the data. So let's wrap this up. What does this actually mean for you as a Python user? It means you can build a whole user interface with simple commands. It means you can totally forget about ever writing HTML, CSS, or JavaScript again. You can drop in cool interactive widgets like it's nothing, and this is the big one, you can share your work in minutes. Not days, not weeks, minutes. And that brings us back to Leslie. She didn't just meet her 20-minute deadline, she crushed it with time to spare. But more than that, she went from being a stressed analyst to being, in her own words, some kind of tech wizard. And that's what tools like this do. They're a superpower. So, really, there's only one question left. This isn't just about saving time.
It's about getting your amazing insights out of the notebook and into the world, faster and better than ever before. So are you ready to be the fastest coder in the Caribbean?
Come on, you've been there, right?
All right. So that's where we're going to start. Here's a little infographic also made by Notebook LM for people who prefer that kind of thing, for what we're going to be doing. And without further ado, let's get started. I'm going to pass on to Nick to show us how to get into the Google Colab. Nick?
Sure, no problem. Great job. Just want to make sure that everybody could hear me.
Yes, we can.
Okay, great. Just give me 1 second.
While Nick is getting ready, and I know my volunteers in the chat, my WiDS volunteers will be sharing information. For those of you who would have joined us, some of you would have received a folder via email. We also have the folder link in the chat, and we'll also be putting the actual notebook link as well that Nick will be going through in the chat specifically. That's also in the folder. So Raphael has put it there for you. So Nick, whenever you are ready, you could take the floor. If you have any questions, if there are persons who actually never use these types of notebooks before and these types of things, please let us know. One of the tips that Nick will recommend is that you save the notebook or copy the notebook rather in your drive instead of trying to work from the actual notebook link that you would have there. And we do have a downloadable one. So Nick, you could always show them these aspects as you go along.
Sure, no problem. So everybody can see my screen?
Yes, we can.
Okay, and just make sure if I go to this Windows Explorer, you can able to see this, right? So I'm supposed to be sharing the entire screen.
Yes.
Okay. All right, great. So for today, we're going to be going through a quick script or notebook in Google Colab. This will help us get a better understanding of the data. We'll go through some of the topics that would have been brought up within the slide itself, and then we can move quickly from here to the actual Streamlit dashboard. We'll start with the raw CSV file of the Titanic passengers. Firstly, we can go to this Google Drive. This link should be shared in the chat. Just let me know if it is. If it's not, I can share it.
It's there, and I think Jaheim could reshare it as well.
Okay.
Yeah, he reshared the whole folder.
So yeah, once you get access to the folder, you should be seeing these different resources, these different folders, files here. From the demo, this will be the data, sort of like a backup version of it. But what I went ahead and did, I created a repo, and I will share this in the chat for everybody. So we'll just go through a quick tutorial of getting this repo set up locally, because I would want you to install the packages in the background while we go through the notebook. So I just pasted the URL in the chat. You can take that URL, go to a new tab, whatever browser it may be. And then this will be an online repository that is, similar to the information inside the folder. So today we're going to be using the technologies Git, GitHub, Python, Google Colab Notebook, and Streamlit. Hopefully you would have GitHub accounts created before. If you do not, while we're going through the tutorial, you can go ahead and create it on your own.
Let me just stick up in because we have a question.
Yeah.
Vindra was asking about the doc with GitHub. Are you able to just quickly give them a little bit of walkthrough of GitHub? We do have instructions, Vindra, but I'm glad that you asked. Could you tell them about Git and what is GitHub and why is it used in terms of this? Yeah.
No problem at all. So firstly, Git is, I'm doing it wrong here. Git is an application or technology that you're able to download. So if you go to a tab, type out Git, download, spell it correctly, and then you have the ability to install it on different machines. So what Git is, it is a version control manager. When you download it locally on your machine, whichever machine it may be, Windows, Mac OS, or Linux, when it's set up, it allows you to create and manage projects within a Git repository. And what that is, whenever you make changes to a specific version of the code base or whatever repository you're working with, you can have different types of files. It doesn't have to be code. It can be PDFs, it can be documents, such as Word documents or Excel documents. Now, whenever you go through and make an edit to it, you essentially overriding the previous changes. Now, some applications provide like an undo, but within Git, it was created for specifically code. Whenever you make changes to code, you can technically undo, let's say you make 25 changes. If you want to undo all that, you'll have to go all the way back to a different version of it before. What Git allows you to do is have multiple versions of the code base. You can go to one branch, make changes there, and not affect the old branch, which would have been your original code base. So that gives you a way to control different versions of the code or files that you have on your machine. What GitHub is, it is a website platform or a web app in some cases that allows you to have another way of storing your code in a cloud-based environment. So the same way GitHub has these things called code, issues, pull requests, and actions, and then we see in main here, these are called branches. These are the same concepts that are in Git locally, but they put these concepts on a website that anybody can access and collaborate globally. If you were making changes to your code locally and you needed to give it to somebody else, you would have had to copy the code and send it to them. Instead, GitHub is a way for you to upload your code to this GitHub repository on our website, and you can add anybody to this repo if you make it private, and they'll be able to access the code. Now, I mentioned private, you could also make it public, so anybody online can access it. So the same way how I copy this link and I shared it to you, this is a public repo. If I were to go, let's say it's this one here, let me go back to my main profile and let me look for something called private, not public. There should be a way to filter, but I'm already here, so I'll just keep going. Yeah, so you see this tab called private. If I go to this repo and I decide to do the same thing, copy this and send it to the chat, and if anybody else that is not associated with this account or repo, if they try to access it, it'll be a 404 error not found. If you do get that 404 error, just let me know. If you don't, and you're able to see the code, then there's an issue. So let me know as well too. So they have different ways of making your repo public or private, and this is a way for collaboration with people globally. And also the Git is a way for you to control different versions of your code base. Is that clear, Vindra? Okay, great. Good. Now, once you go to the GitHub link for the WiDS Workshop Starter Kit, all right, great. You'll be able to see this interface. And what I would like you to do is go to the button called Code, select the dropdown, make sure HTTPS is selected here, and then we will copy the URL. We will go to our search bar. If you're on Windows, you just need to go to search and type out CMD and press open. If you're on Mac, I believe it's called terminal or something like that, and Linux is a different word, but for Windows it's CMD. So you can just do a quick Google search of how to access terminal within Mac OS or Linux. Now I need to make sure that I want to put this repo in the correct place. So this is the folder, subfolder on my desktop that I want to place this repo in. So I'll just make sure and open up the command prompt from here. If you have something called terminal, you can use that. If you're on Windows, it's only available in Windows from what I know. to type out CMD here and press enter, and it opens up the terminal within this folder here. Now, the command I want to run to make sure I get this code base locally is git clone and then paste the URL. Once you paste it in, you have git clone and then the URL. You press enter, and then you can see here that the code base was cloned locally. So the same code here is the same thing on our repo here. Well, my repo. Let me go back. Good. Once we clone it, we need to go in or change directory to the code or repo that we just cloned. And the name is WiDS, wrong one. WiDS workshop. Good. And then inside of here, we're going to do two commands. The first command that you will need to run, this is dependent on if you have Python installed. So if you go back to the same folder that was shared to you in resources, there should be some resources on creating an account on Kaggle, creating an account on GitHub, on Streamlit, and also installing Python as well. Once Python is installed, you should be able to run any Python command. To verify that Python is installed, you can type out the keyword Python, all common, dash, capital V. And once you press enter and you see Python 3 point, whatever the other number may be, from you, it may be different. It may be 3.12 or 3.14. For me, it is 3.11. Once you see this pops up, that means you have Python installed. After that, you can run the command Python -m venv venv. What this is doing, it's taking Python, the same application we installed. We're telling it to run a module called venv, and then we're telling it to create the folder called venv. So the first part here is the module. It does not matter which Python you have at this point, but if you were to work on other code bases, the version of Python will matter. Yeah, now for this command, so the venv, the first one, that is the module, and then the second one here is the folder that I'm creating. You can call it venv, or you can call it folder, whatever you can call it, but make sure it's something to easily understand why it's being called that. So for consistency's sake, I'm just calling it venv. This may take a couple seconds to set up. Okay, good. And then once you do that, you should see there's a folder called venv here, or you can look here and see that this folder within the Windows Explorer at venv is also there. Once that is installed, depending on where you set it up, inside of this folder, there will be another folder. It's either called bin or scripts. If it is bin, that means you're on Linux. If it is scripts, that means you're on Windows. So given that my environment put bin, even though I am on Windows, I'll just quickly go to my Linux environment on my machine. Now, while I'm setting up, the next command I want you to run, just to quickly get to this. In the repo, you'll see different commands I'm running here. So we just ran Python -m venv venv. The next one is pip install -r requirements.txt. For this command to work, you need to make sure you're within this folder because the requirements.txt file is there. This may take a while for me. Okay, good. Let's do this quickly. So as you can see, I'm within the WiDS workshop starter kit. So I run this command inside of here. And then once that is done, I would also run this command. to install the packages. As part of the code base, I made sure to include this requirements.txt file. And this tells Python the different packages I want them to install. This is something familiar that you should be getting acquainted with if you do work in other Python code bases. Let me see, is it done? Good. And now once I paste the command that I copied, pip install -r requirements.txt, and once you press enter, you'll be going through this set of steps. But this will be one of the issues that may occur here. The issue is we set up the virtual environment and then we try to install the packages. The virtual environment is to provide a safe place to install packages that we don't want on our machine. So what we need to ensure once we set up the virtual environment is to activate it. So the venv is the folder. For Linux environment, you would type out source. If it is a Windows environment, you would type out venv scripts activate. But I'm in Linux right now, so I need to type out source venv bin activate instead. Once you do it once you use the correct command on the specific OS you're on, you should see this brackets venv show up for you. And then afterwards, we can go back and run the pip install -r requirements. Why? Once we activate this environment, all these packages that are being installed here are going inside of this folder. If we didn't activate it, all these packages that would have been inside the requirements.txt would go on your machine locally. Sometimes it is good, but sometimes that may be bad, because we only have 9 packages in requirements here, but there are some code bases that have about 100 different packages. So in that case, you don't want to install all that 100 packages on your machine. And this is why we have the virtual environment, or venv for short. Is that clear to everybody? Anybody's lost at this part? Want me to go through anything?
Nick, just
The
checking. I think Vindra had asked, I don't know if this was answered before. Yeah, the Python version, does it matter?
The Python version doesn't matter at this point, but if you work with a different code base, it wouldn't matter. But for this example, it doesn't matter.
Okay, excellent. Thanks so much. Vindra, I hope that answers your question.
Yeah, and at this point, you can see, look how long it's taken to install different packages. So we can leave this in the background and then we could continue or proceed with the notebook here. Now, great. Once you have access to the notebook, you should be able to see this interface on Google Colab. We have the familiar interface with our file, edit, view. The file allows us to locate in a drive, to load a file, open a playground mode, new notebook in a drive, open notebook, upload notebook, and whatever it may be. If you have access to this, right now it's only in view mode. You won't be able to edit anything. Or if you do, the changes will not persist. For that, you need to say save a copy in Drive or save a copy in GitHub. You will select save a copy in Drive to make it easy for you. Once you select that, it will take this copy and create one under your account in Google Drive. Once you have your version under your account, you select connect to a new runtime. And when you see this, these statistics that are showing up here with the green tick, and then you have RAM and disk, that means you're connected, and then we can continue. So a quick background, the sinking of the Titanic is one of the most infamous shipwrecks in history. On April 15th, 1912, during the maiden voyage, the widely considered unsinkable RMS Titanic sank after colliding with an iceberg. Unfortunately, there weren't enough lifeboats for everyone on board, resulting in the death of 1,502 or 1,502 out of 2,224 passengers and crew. While there were some elements of luck involved in surviving, it seems some groups of people were more likely to survive than others. And in this challenge, we will build a predictive model that answers various questions. What sorts of people were more likely to survive using the passenger data? Example, name, age, gender, socioeconomic class, etc. If you want to see more about the Titanic dataset, you can select this link. And yep, you'll just select the link here. And this is the dataset here. You can download the dataset from this link, but if you do have the same code base that I shared with you, you can see the data folder has the same dataset here. Now we need to upload this data so we can analyze it. Let's quickly go to this files section here. Select the upload arrow. Navigate to the directory that we clone the repo. For me, it will be in here. WiDS Workshop Starter Kit, data, then train.csv. And this gives us a warning stating that any files that is uploaded here will be deleted when the runtime is terminated. So make sure you have a backup version somewhere else. And that's okay for us because we already have it locally on our machine. Now, this tutorial will give us a quick walkthrough of a full data science workflow using 5 questions. Who were the passengers on the Titanic? Who survived and why? Can we engineer better features from what we found? And can we build a model to predict survival? And then at the end, we'll just show a summary of what artifacts we produced. The first part here, we need to import some libraries that allows us to go through the analysis steps and also model creation and data preparation. The first part, we have pandas. This is for data manipulation and working with structured data sets. We have NumPy. This gives us the ability for numerical operations on arrays and also mathematical computations. We have OS. This interacts with the operating system. We have the import matplotlib. This is one of the libraries that gives us basic data visualization abilities. We have Seaborn. This is built on top of matplotlib and gives us more advanced statistical visualizations. We have JobLib. This is something that allows us to load and save the trained machine learning model that we created. We have the pre-processing tools. The first one is the standard scaler. This allows us to standardize numerical features. We have one-hot encoding. This converts categorical or string variables into binary. We have the simple imputer. This allows us to impute or add values based on a certain statistical measure or value. We have column transform. This applies different preprocessing steps. We have the pipeline. This sets up the preprocessing chain and modeling together to make the workflow easier to debug and set up. Random forest classifier. This is our model that we're going to use. And then, as with any data analytics or data science or machine learning process, we need to have our metrics to ensure that our model is performant or accurate. So we can go ahead, make sure and select the cell itself. Then we can press the run button, which is, you can see here, this play button. Or you can go a little faster and press Shift Enter. Once you run it or press Shift Enter, you should see the green tick show up, and that means everything was run successfully. Now we are defining some paths here. We're setting up where the train.csv is. And we're setting up our Titanic clean basic.csv and then the plots where we're saving our plots. If we press Shift Enter, nothing happens. That's good because you just have the green tick. That means everything ran successfully. This gives you a quick understanding of the code that was run from before. So we can go through this on your own to get a better understanding of it, and I will move on. After that, we have the setup for the Titanic clean basic CSV and the different artifacts that we're creating, which is the model, and then afterwards the plots. We run this to set it up and we continue. If you want to create a cell on your own, when you hover at the bottom of the page, or the cell, sorry, you have the code button and then the text button. Code creates a code cell where you can write Python code, R code, and Julia code. And the text allows you to write text that will be formatted differently depending on how you format it. As you can see here. So right now, this cell here that I'm on is a code cell. This cell here that has Q1, who were the passengers on the Titanic, is a markdown or text cell. Our first question, who were the passengers on the Titanic? To do this, we will need to load the raw data. So we use something called PD, which you can look back up here. From the imports, we imported pandas as PD. So we use pandas to read the CSV, and then we use some simple methods that are part of pandas data frame to understand the shape and what data types we have. When you run this, you can quickly see that we have 891 passengers and 12 columns. These are the different columns. And then we have the column types. So every good data science project starts the same way. You look at your data before you touch it. Our first question is simply who was on the ship. By us being able to see that we have 891 rows, 12 columns, it says I want to know what kind of data I have before I do anything else. The numbers I can average and the text I need to encode and the D types here tells me that at a glance. So I have passenger ID survived that are all integers. Once you see objects, these are strings, and then floats, which is an integer just with a decimal point. So a float or a decimal, you can think about it as. And then we use something called df.head to quickly see an overview of the data we have available. As you can see, the name is a text, which is an object. The sex is male or female, which is an object, so that's a text or string. The age is 22.0, which is a float. Then sib_sp is an integer, which is in64, ones and zeros. After that, we need to understand the missing data. This is the first thing we need to always run on a new data set. Once we run this, we can see that we have 3 columns with missing data. The cabin, this is 77% missing. At this point, with that amount of data missing, this is not a column. This is an assumption. You could think of it as, meaning it's not important right now to us. So this is something we want to drop because it's missing so much of data. Afterwards, we have the age. This is 20% missing. We can always fill that in with imputation. And we have embarked, this just has 2 missing. We can also fill this in with imputation. The key observation, we have 77% missing. We'll drop it later. The age, we'll fill that in with median, and then the embarked has just 2 missing rows. We will fill that in with most frequent. Afterwards, we can run the next cell, and this displays the plot that we want to create to understand the data set better. So just a quick run through of it. At the beginning here, we pick the age, P class, and sex, because from the data set we have, these capture who was on board. So we start off with the subtitle, or the subplot title. This is questions, who were the passengers? You can see that display here. Then we set up the first plot we want to display. This is the age distribution. Then afterwards, we set up the second one. This is the passenger class, and then the gender split. To do that, we need to take the age from the data frame. We need to drop any empty values, just in case, just to be safe. We are binning it with 30. We provide a color, an edge color, and an alpha. These might be a little bit difficult. I don't think I have enough time to go through everything or every part about it, but we can just associate it with the plots that are shown. So the axis.histogram is telling Python code that we're displaying a histogram, and these are the configurations for that histogram itself here. Then we set the title, which is age distribution, which is the title here. Then afterwards, we set the X label, which is age years, and that's below the X axis. And then the Y axis, which is .set underscore Y label, the count. Once you have this set up, you'll just go through enumerating to do a little bit more configuration in gender counts, so it looks a little better. Then we plot it using the tight layout. We save it to a PNG file that we can use or download later and show somebody else. And then we use the plt.show to show the plots in the cell. For this one, we're asking who were the people on board. The answer that we can see from the plots here. For the first one, the age looks to be mostly young adults, around the 30. The median age we have here is 28, so 28 will be young adults. Then we look at the passengers by class. You can see the class here. 1 is luxury, 2 don't have the value here, but I could call it intermediate, and 3 is economy. So we can see there was a large number of 3s. So we can state that the median age of young adults, most of them were in 3rd class. And then with the gender, we can see they were mostly males, so more males than females. So we can make the statement that mostly young adult males, and most of them are in the 3rd class or economy. This is our baseline. Everything we learn next is relative to this population we have here. Next question, who survived and why? To understand this, you'll just take the same data frame we had before. We want to know who survived, so we're using the survive variable from the list of columns we had up here. You can see survived is here. Then you can see, using the mean based on a survived column, the overall survival rate is 38.4%. I think there's a question. Okay. Now from this, the question 2 is, who came off it alive and why? After we run this cell, we can go ahead and run the second cell to see the plots. Let me make sure I have it here. Hopefully this works. Okay, good. Now you can just follow me if you're following along with the code. When we going through creating the plots, there's something called plot.close. Before that, you can just add this small code in plot.show, and that will show the plots on the screen before it closes. Let me run this one more time. And here we see who survived. From this data, we have female being 74% and then male being 18%. And then survival rate by class, we have 63 for the first, 47 for the second, and 24 for the third. So based on this, we can make the statement that women survived at 74%. Yeah, add plt.show above the plt.close. So right now, looking at this data from the plot we have here, we can state that females had a better survival rate than males. And then the first class citizens or people in the population had a better survival rate. The next one, we can see the age distribution by survival. From this histogram, we can see that children under 10 had a high survival rate. He survived as a green. And older men had very low survival rates. So from this, we can make the assumption or the statement that age matters, but it's a softer signal than gender or class. And then the next plot, the class plus gender interaction. This chart, I want you to remember, almost every first-class woman survived and almost every third-class man did not. So this essentially reinforces the policy, women and children first, except it was also wealthy women before poor women, unfortunately. And this is why we do ED. A model could find this pattern automatically, but we wouldn't understand it from the model. So by doing this visually first, we can later check, does our model agree with what we saw? So some key insights: gender and class aren't just important individually, they interact. The model needs to capture this. The third part, can we engineer better features from what we found? When we're doing feature engineering, we don't want to feature engineer on the original data set. We want to create a copy. That is why we have this df.copy. So we create a new variable, df_eng is equal to a copy of the data frame. From the data, we have the different titles. We want to feature engineer that because we saw that gender matters a lot. So titles like MRS versus MS add extra information: marital status, age hints, and social standing. So we feature engineer this, and then we just display the title distribution after we do that. You can see this line here that we're taking MLLE. I believe that is the French abbreviation of mademoiselle. And then we have MME, and I believe that's the French abbreviation of madame. So MLLE is Miss, MISS. MS is also Miss, but MME is MRS. And afterwards, we create two new variables, family size and is alone. To understand what family size is, we're taking the SIB-SP and then the parent and child. So the sibling spouses, parent and child, and add in 1 to get the family size. This is how we feature engineer a new variable. Family size wasn't there, but with the other variables we had, we're able to add it together to create something called family size. After that, we have is alone. This is basically taking the same family size we just created and checking to see if that is equivalent to 1. If it is, that means this person is alone and they had no family members. So anything greater than 1 will be the family size. Once it's 1, that means they are alone. And once we do that feature engineering, we'll go through the same steps as before in creating our different plots. So we can go here, you can see that plot.close is here. We want to say plot.show. And then we run the cell and we see a plot showed first. Now, before we move on, so handling the missing values, this is important. Once we create the different features, we're going to handle some missing values. For the age, we want to fill this in with the median. It is simple and robust for beginners. The second part, the missing values that for embarked, you want to fill this with mode or most frequent. And then we want to fill the fair with median, good practice, even if none missing is in true. So even though fair may not have had anything missing, we still use this as good practice to understand how to impute values with median. If you wanted to use mean, you can just update median to mean. And that's how you do it. After that, we want to drop columns we don't need. This is the carbon because it's 77% missing, too sparse to be useful for this one. Then ticket free-form text with no obvious pattern for beginners. The name, we already extracted the titles from it, so we can drop that. And then the passenger ID, this is not a real feature, this is just an index, and it provides no value for us. To decide which one you're using mean or mode in, so mean is for numerical values. These are values of integer or float. And mode, this would be better for categorical values. So the mode is a measure of average or the central tendency. And the best choice depends entirely on the type of data. Yeah, it's very situational, and it depends on the domain knowledge as well. So for beginner, you would go with the basic assumption, what is the data type? You can go off of that. You can do a first analysis and see how it works out. And then when you get a better understanding of the domain knowledge, then you can go back and update it to the correct either mean or mode based on domain knowledge afterwards. Because sometimes you won't start with domain knowledge, sometimes you may. Yeah. So categorical variables, you would use mode, the most frequent category, and then numerical scores, you would use mean. This is the default and most powerful. Median is also another powerful one. If you want to use mode, this is to represent the typical value. So using mode, you would use that when you understand the data better based on the domain knowledge. Because you're essentially, if you use mode without domain knowledge, you're essentially inputting bias into the data sets that will create poor decisions later on. So it's always good, safe assumption to go with mean first for numerical and mode for categorical or object data. So we created the features. We can see the survival rate by title. Someone who is a MRS or Mrs. and Miss, they have a higher survival rate because MRS and Miss, these are females. And then the survival rate, you can see the highest survival rate is a family of 4. So going through that process of filling in the missing values and dropping the features and creating new features, this is cleaning the data set and preparing it for modeling. Once we run the cell, then we can go ahead and say, can we build a model to predict survival? Answer is yes. How are we going to do that? We're going to use something called random forest. Why random forest? It handles both numeric and categorical. It's relatively easy to set up and interpret and tends to perform well out of the box. The important thing to note here is interpretation, because sometimes there are machine learning models that are black boxes. This is more in the realm of neural networks and also LLMs. These are black boxes. We don't have a good understanding compared to our understanding of simpler models. So sometimes when we start off, we want to use a model that we can easily interpret to understand the patterns that model was able to find. And then later on, we can make a more complex model. To prepare the data for model training, we need to create our X and Y values. So the X value is all the features that aren't the target variable, and our target variable is survived. So we state df_clean.drop survive. So we're dropping this. So X has all the other features except survive. But we also need to capture the Y, which is the values of survived, because we need to use that to test that the model performs well after it's trained. If we were to keep survived in X, we're essentially training the model on the answers, and that is a very highly overfitted model. We don't want that. Afterwards, from the columns and the data types we saw from before, we saw that these values were ints and floats. So ints and floats usually indicate numerical features, and then objects usually indicate categorical features. So we just set up our numerical and categorical features, and then we split the data set. We're using an 80-20 split here. There are other ways of splitting it. There are 50-50. There are 70-30, 90-10, 99-1. The way you split it is dependent on the data set you have and the amount of data you have as well. If you have, let's say, I would say 10 million, 8820 is still good. If you have a small amount, let's say 1,000 or below, 8020, 9010, and sometimes 99.1 is also good. But to know which one is best to use, you'll need to do an analysis of the data to see the distribution of it. For now, a good baseline is 8020 split. We use something called the train test split. What it does, it takes the original X and Y and splits it up. The X train and Y train, it takes from here and splits it into a train data set and then a Y train. So the X from here becomes a split into the 80 train, and the X test is the 20 test. Once we set that up, we make sure and specify test size. 0.2 means 20%, and this is how we specify the 80-20 split. If you wanted a 70-30 split, you would say 0.3. If you wanted a 98-10, you would say 0.1. We'll just print out the training samples so you can see the splits, and then this is how we set up the pre-processing and model pipeline. We're using something called pipeline to make it easier to configure the setup for the imputation, the scalar, and the one-hot encoding. So we set up our numerical pipeline first, categorical pipeline second, and then we have our pre-processing. I know I'm going through this a little bit fast. They have the different comments to get a better understanding of it, but it's not too difficult. And if there are any questions afterwards, you can always ask me and I can explain. Once we run the cell, we can see we chose random forest because it works well with mixed feature types. It's robust to overfitting, and we can expect feature importance for interpretability. The training sample is the 80-20 splits, 712 and 179. You could always verify that the amount of data we had from before. You can see it up here, 891. If you were to split this 80-20, that should be the correct values. If you want, you could always verify on your own. And once we have that, we're going to train the model. So from before, we stated model is equal to the pipeline from the preprocessor we set up and the classifier. And then we're stating model.fit on the X train and the Y train. After we fit the model, this is our training here. We will go ahead and predict. Now this is our evaluation. So we're taking the Y pred and then doing an evaluation. Taking the values from the prediction on the 20% that we left out. And then we're using accuracy and ROC, AUC to understand how well the model performed. This is a small amount of data, so the model trained relatively fast. If there was 10,000 or 100,000 rows of data, it may have taken about a couple seconds long. If there were millions or 10 million, it may take about a minute or two, depending on how complex the model is. We use a basic classifier, so it's able to train fast. Model performance, we have 82% accuracy and 88% ROC AUC. These are some metrics. You can do some investigation on your own to understand it, or the resources and YouTube videos we have on the widstt.com website. You can see the precision is 84% and 81% for zeros and ones. You recall an F1 score. These are relatively within the same ballpark, so the model is performing well enough for now. After this, we have something called SHARP. This allows us to get a better understanding of the model after it is trained. You can only use this after the model has been trained. If the model isn't trained, this will not be important to us using the SHARP for interpretability. So we need to make sure that the model is trained before. So same step again, you can go ahead, say plt.show, run the cell. And then from this graph, we can see the top 5 bit values or columns here. we have the title, we have the sex female, sex male, P class 3, and P class 1. These were the top variables that were important to the model to get an understanding of the pattern and make accurate predictions or perform accurately. Afterwards, we can see another version of it, of the sharp model. We can go ahead, look for plt.close, plt.show, run it. May take some time, hopefully not too long. And here we go. This gives us a better understanding of sharp. So the model from this diagram here, the model confirms what our EDA showed. The sex, P class, and title are the top predictors. And title are the top predictors of survival, and the random forest achieves around 83% accuracy and 89% AUC ROC. Now, at the end of this cell, you can see here we save the model. We save this model so we can use this later on in the Streamlit. And then at the end here, what we created or what we produced. So we generated the following content, artifacts ready for the Streamlit dashboard. We clean the CSV, we train the model, we created our plots, and then the next step is to create the Streamlit dashboard. Below here are different functions that are left for you to do as an exercise. With the interest of time, I'll just go straight to the Streamlit dashboard, but you can do this on your own. And once you fill out the to-dos here, and once you complete it, you'll be able to run this workflow, and basically the same output you saw from before with the other cells we ran just now will be printed out below. But this is just a cleaner way, of doing it. So good. Give me, say 2 minutes. Let me get the next part set up. And if there are any questions, you can put them in the chat or anything you want me to explain, you can always put it in the chat.
In the meantime, while Nick gets set up, anybody has any questions, any comments, any feedback? I know certain portions may go a little bit faster, as Nick mentioned, but we have all the materials there for you. And we do encourage you to, yes, and I mean, really, so far, Nick, excellent job, both Nick and Neslian so far. Also want to let you know that if you do pursue any of the questions, what he went in, and thank you, Jaheem, for resharing the folder. If you pursue any of the activities he has in the notebook and you have trouble with it, or you need to get some advice on what to do, or you have any questions, feel free to email us at widsttgroup.com. If one of my mentors and our volunteers could put that in the chat, widsttgroup@gmail.com, and we'd be happy to get your questions answered if necessary. So please let us know. I think Vindra, in the meantime, Nick has a question on why is feature engineering done on the copy of the notebook? Is it that what you're asking, Vindra? He said why is feature engineering done on a copy?
I think he meant on a copy of the data frame.
Of the copy of the data frame, yes. Oh yes, a copy of the data frame. Go ahead.
So yeah, just a quick explanation of that. Let me see. Yep, so performing feature engineering on a copy of your data sets. This is better than modifying the original data in place. This is a crucial best practice in data science for several important reasons. Even though it consumes more memory, since you're storing 2 different versions of the data, the benefits in terms of reliability, reproducibility, and flexibility almost outweighs that cost. So the first thing is data integrity and safety. This avoids irreversible mistakes that you would have done on the original data sets. So if you create a copy, you made a mistake on the copy, nothing happens to the original. So you can always go back to the copy, create the next copy, go back to the original, create the next copy, and go again. Because sometimes you may have human error. The next one is you would call this methodological rigor or data leakage prevention. One of the most critical pitfalls in machine learning is data leakage. This is unknowingly including information from the test set when training the model. So this leads to overly optimistic performance and estimates during training and poor performance. So performing transformations in place on a single shared data set before splitting it is a common source of leakage, this is why we create a copy. So we could do the transformation on the copy and train the data on the copy itself. Is that a clear explanation? Okay, good. Great. Great. Once that is set up, let's go and in a new tab, type out streamlit.io, or you can just copy this link and go to that website in the chat. Once you go here, there should be the free pro buttons here. Want you to select free. Once you select free, you should be able to see this page if you already have an account. If you don't, you need to go ahead and create an account, go through these steps, the multi-factor authentication and whatnot. I am going to delete this because yesterday I deployed my version of the application. But for this tutorial, I'm going to show you how to go through that steps. So what I need you to do, let us go back to this repo we have here. You have this version locally on your machine. If you want to see what it looks like or interact with it in an easy way, we can use an application called VS Code. If you have it installed, you will be able to, within the command prompt, type out code dot, or in the File Explorer, right-click, open with code. Or if you don't have all that set up, you can search for VS Code. You can open it up. Hopefully I don't have all code from before. I do. Let me just quickly go to the file here. We can open folder, search for the folder we want to open up. Desktop, Windows 2026. Windows Workshop Starter Kit. Once you see that name highlighted here, we select this folder to open, and then we open it up here. This is how you open up your code base in VS Code. But before you do that, I want you to make sure you have your own version of the code base under your account. Right now, what you would have done is clone the copy from my account, but you will need to select the fork button here. Create a fork, leave the repository name as is, and then select the create button. I can't do it because I already have this repository under my account. But what you're doing when you create the fork, you're going to create a version of this repo under your account. So I would like you to quickly go through and create that fork, clone your repo locally, and then you can proceed. While you're doing that, I will just quickly open up this command prompt. This one, right? And I'll show you the command once you have, yeah, there is food. So once you have these packages installed and you have the virtual environment set up, you can type out Python, well, not Python, sorry, Streamlit run apps /app.py. And once you have the packages installed and you're in your virtual environment, you run this in the terminal, give it some time, a couple of seconds, and then you'll see this pop up here. Now within VS Code, we can go through to understand the code a little better. Underneath the apps folder, we have the app file. This is our Streamlit dashboard. You can go through this on your own to understand this code, but I would go through a simple Streamlit application just to end off this tutorial. I'm just going to quickly show you how you can deploy it so you can have this dashboard so you can show anybody and share with other people. But the quick tutorial I'll go through should give you a good understanding of the code that you'll be seeing within this dashboard. Should be able to do this in 15 minutes, more or less. It'll take a couple seconds to set up. Just quickly doing this to make sure that it could run locally. No issues when you have it locally. Once you have no issues, then you can go ahead and deploy. Once you see this bike, wheelchair, swimming, rowing, stick figure stuff, then that means everything is ready. And there we go. So we have different tabs. We have the explore the data. This is the same plus that we would have seen from the notebook. It is interactive. So if you decide to select female, it will update to hide female. And as you can see, double click on the legend to show that one. So I selected once on female to hide female and only show males. I select it back. Now both of them are showing. I double click. And I do double click on this trackpad. I guess I can't. But if you double click it, you should be able to see the specific category that you want to see here. You can also hover over it to see the values. You can also go to the filters on the side. You can remove female, and you can see everything updates in an interactive setting. The overview total passengers that are male, 577, survivors 109, 18% survival rate. If I go back, select female, and if I remove male, you can see everything else updates correctly. Total passengers of females, 314, 233 survived, so 74% survival rates. Then the next tab will be our predict and explain. This is the model that we created and trained. So if you want to predict the survival rate of a wealthy woman, so this is someone who's in first class, you will just select one. Make sure gender is female. Make sure the age is 30. That is 30 already. And then the fare is 80. You can select the plus button, or we can just update the value here. Wrong one. We can update the title to the correct version. And then we can predict survival rates. And then we see that this person would have had, this new person that we're adding to the data sets would have had 96% survival rate. And then it takes some time to show the sharp interpretability, but once it shows, you'll see the reason why. Give that a couple seconds, and I'll move on to this one quickly. Once you have Streamlit set up, once you have your repo forked, we need to select Create App. You need to select Deploy Now for GitHub. They will have the list of repos. And then give it a couple seconds. Maybe the Wi-Fi is not going through. Here we go. We can search for the repo that we would have forked. Make sure you have the correct name you're writing out here. The drop down would show it for us, the autocomplete. We select it. It's this one. Make sure this main file is correct. So it's not streamlit_app.py. It is apps/app.py. We can update this name, but we can leave this as is. And then we can select deploy. Once you have your fork of the repo, you connect it to Streamlit, you set up those configurations, and you press deploy. It'll take a couple seconds, and then you have this application deployed that you could share to anybody all over the world. Now here you can see, this is the interpretability of the model. Yes, the Streamlit likes food, so there's a lot. Your app is in the oven being prepared. And once everything goes smoothly, with no issues, no hiccups, this will be shown. I'll give it a couple more seconds. And here we see the key takeaway here. So this is just giving you the code and showing you how to deploy it. we can see it's basically the same thing we deployed, but we can look at the URL here, and it's a different URL. This is a shareable URL. If you want to share with somebody, you would select the share button here. You would go to social or embed. These are different ways of sharing it. You can select invites, copy link, and then you can paste it or share it with whoever you want to share it with. This one here is local, so you're not seeing this version of it. I can make changes locally and you wouldn't see it. But if I make changes and I update this version that is deployed, you will be able to see the deployed version. Now, just quickly let me know if you're able to click this link I shared in the chat and you're able to see the deployed version of the application. Hopefully, yeah, you're able to see it. So what we're going to quickly do is go through a brief tutorial of Streamlit. In our VS Code, we want to create a new file, streamlit_tutorial.py. Press enter, and you should be able to see this. Make sure you have the .py. This is the Python extension. And then let us go. You need to import some libraries. So once you are working within the environment that you install the packages, I have some AI installed, so I may get some autocompletes, which would be good. We need to import Streamlit. You say as st. What this does is this gives an alias. So instead of typing out Streamlit all the time, you're just going to type out st. You're going to import pandas as PD. Import numpy, trying to be helpful, and to import plotly.express as px. Now we want to set up our page configuration. This is a basic Streamlit dashboard, nothing too fancy, not as fancy as the other dashboard from before. You need to type out something called st, taking the Streamlit package, .set page config, setting the title, Streamlit intro, and setting the layout wide. So once I go back to the command line and I run the command streamlit run streamlit tutorial, and I run it, and it sets up, you'll see what this looks like. Now, as we do this multiple times, we can see the basic commands that we need to repeat every time. We need to do streamlit run, and then the file that we want to run. Let me go open this up. Take this over here instead. Give this a couple seconds. May take a little while. And while that's doing that, we can move on to our next one, a quick one. So we do something called title. We want to give a title to our web page. We will use st.title. And as the AI is helping me out, we can state Streamlit tutorial. We also have something called st.header. And then we also have something called st.subheader. These provides headings and subheadings on our web page itself. And then there's something called markdown that we can display on the page. So we can use st.markdown. And then in here, we can use the same syntax to generate different markdown. And the Copilot is being very helpful here to show me what can be done. Make sure everything is running good. Go back to the page. Refresh if there's any issues. And what we are rendering on this page will show up. Just give it a couple seconds. Now there's something also called st.divider. This will be familiar if you look through the dashboard we just deployed. This creates a line on the page itself to be able to categorize or section off different parts of your application. So we created a different section and we can say st.header, and this is block 2, displaying data. And here we go. This is what it would look like once we have that code written out and are using the st.divider, st.markdown, st.header, st.title. So we can look at the title here, Streamlit Intro, Streamlit Tutorial. We can look at the code, Streamlit title is Streamlit Tutorial, which associates to this. And then up here is the set page config, so the page title. And let me quickly create a sample data frame. This will be a sample data frame that we're using. And then we could use something called ST columns. So we want to create columns first. We have call 1, call 2, and call 3. So we state ST columns is 3. So we're creating 3 columns and we're providing it or assigning it to 3 variables, call 1, call 2, call 3. And then we're providing call 1 metric, call 2 metric survivors, and then the metric is survival rate. We're using another markdown, and then we're stating st.data frame. And we're using st.divider. Second, once you make changes, however, you need to refresh the page. This is going to happen locally. If you want changes to be done on the deployed application, you need to make sure and have these changes on your GitHub and then redeploy it from Streamlit. And here, yeah, at the end, this is basically a quick introduction to Streamlit and how to deploy your dashboard so anybody can access it over the internet. Are there any questions? Feel free to ask.
It was excellent. Thank you so much, Nicholas. On the nose of midday on our end. Are there any questions? Anybody has any questions, comments? Really want to give Nicholas a virtual round of applause. Very, very comprehensive in terms of how you would have explained. I think everybody has really picked up quite a lot. And I know it's a lot in terms of the session because we do have a limited time, but feel free to let us know if there are any elements that you all would need further explanation on. You could feel free to reach out to us. Are there any quick questions? Anybody has any questions or comments so far? Feel free to put on your mic or let us know in the chat. I think Vindra asked, how does Streamlit know what charts or graph to show? Is it all from the Python code we did before? And also, as the Streamlit page is interactive, does it generate its own code in the background?
Yes, so the package, the Streamlit package, in the background, they have basically the abstraction over all the setting or the configuration of the HTML, CSS, and JavaScript. So they technically use that, but they use Python code to simulate that on a web page itself. They do that in the background, and all you need to do is use these different functions that Streamlit provides. Now, it's shown here. This is an example of a bar chart. And we're using called st.plotly underscore chart to display a chart on the dashboard itself. I'm going to share this code to the GitHub repo that you can access. So what it does, once you use the correct functions from here, it will take the code that you wrote in Python, manipulating the data, take that data and display it on the web page using the Python code. Let me see if I could refresh to show. Yep, so it does generate the own code in the background before it shows on the screen. And then how does Streamlit know what charts or graph to show? That is where you come in as the developer. You decide which chart you want to show from before. So I'm using Plotly. I'm saying PX, which you can see from up here. Plotly.express as PX. I set up the values. This is the figure I want to, or the plot that I want to display. I'm stating st.plotly underscore chart to display that, giving it a caption. And then this is how Streamlit knows to display the Plotly chart. Sure, st.write. So I know I would have gone through a bit fast on what these things are. There is no shame in using the AI to help understand what is going on. So if you go back to the notebook, you can see you have access to Gemini for free. So you can always just select a cell, and then you can see here. And then you could ask Gemini to explain the code that is going on. So if you do ask Gemini to explain the code, there is a limit to the amount of questions you can ask. So if it's still too complex to understand or you don't understand, you can always send an email to WiDS TT. You can interact with one of the mentors, either me or somebody else, and we can help go through any gaps in understanding. Yeah, I'm going to show a graph on the dashboard. Just make sure it shows up now. And there you go. So this code here, it takes this plot, takes the X and Y from the data, the dummy data we created here, and then it plots it on the dashboard here. So this chart here for survival rate by class sample data. It is taking this dummy data here, sample data. It's passing it to this variable called survival by class. It's going to do something called group by. So it takes the class and survived, takes the mean, we set the index. Now this survival by class has the data that we want to display. And then we're stating the variable figure, or FIG, is equal to px.bar. We're passing in the data we want to display. We're setting the X and Y, so X-axis, Y-axis, the title, labels, range, and color. And then once that is set up, we're taking FIG, passing it to this function, plotly underscore chart, telling it to use the entire container width. And that's how we get this chart to display on the dashboard itself. Is that good? Wasn't too much to go through with the code there. Or if you want, I can go through again.
This is great. And at least Ragari also mentioned that you would also have the assistance of Gemini in a lot of these tools. So we have all of these large language models, the generative AI that could help to generate some of the code as well. Of course, be mindful it may have errors, but at least it gives us start, especially for those of you who may trying to be toggling with the actual code for some of the procedures. That would be helpful. Of course, this would have come up in the last 2 years or so when we first started doing these workshops. We would have written a lot of this code from scratch, right? Vindra also asks, what are the hyperparameters mentioned earlier by Leslie Ann? Did we use any of these here?
Give me 1 second. I'm just trying to get another thing set up here after I leave. Okay, so what are the hyperparameters mentioned earlier that we use? Yeah, so we use several hyperparameters. This is when a machine learning model learns, it adjusts the internal parameters. So things like weights in a neural network or the split thresholds in a decision tree automatically from the data. We never set those directly. So the hyperparameters are settings you choose before the training that control how the learning process happens. Let's go back to the code. We'll go to this should be similar to the notebook. Let me look for, this is a lot of code. Excuse. Right about here. So this part here are parameters to the model, but they are also the hyperparameters. NS underscore estimators, this is how many individual decision trees the forest builds and combines. So more trees generally means a more stable, accurate model, but also slower training. So if I had this set at 1,000, this model would have taken a little bit longer to train. So there's a lot of things that is dependent on how long the model trains. If you have 10 million data points that you want to train on, that will make the model take longer. If you provide more estimators, that will also influence the length of time the model takes to train. So this n estimators here, this is a hyperparameter, and then max underscore depths, this is another one. This limits how deep each tree is allowed to grow, sorry. Without this, trees would keep splitting until they memorize the training data perfectly. And this is a problem called overfitting, where the model learns the noise rather than the signal. So capping it at level 5 or 5 max depth forces the model to find broader, more generalizable patterns. And then our random state, this isn't really tuning, it's just a seed, so the results are reproducible. Is that clear? Or did I go a little too fast? Want to re-explain anything?
Is that okay for you, Vindra? Yes?
Okay, great.
Great. And I think, well, we may be out of time now. We're a little bit over time, but if you want to continue these conversations with us, feel free to reach out to us via email. Nick and Leslie, I will be happy to answer your questions based on today's workshop. We're really happy to have you all here to answer the questions as well. And I also want to remind you, there's a feedback form in the chat. You will get a copy of the recording in your email with some of the additional links that would have been shared. And also a reminder that we do have an upcoming workshop next week, which is based on we're creating dashboards with Power BI. So we would also invite you all to sign up or to share with your friends as well, to have them really come into these outreach workshops and build these skills. And also you can let us know what else you would like to see in terms of workshops, and we'd be happy to facilitate as well. So thank you very much. And Vindra, thank you for your questions. And I want to thank everyone who has attended today, and also thank Nicholas and Leslie Ann for a very comprehensive workshop. Thank you all for really being very supportive in the community and helping everyone along. And we will keep in touch with you all. Feel free to follow us on the social media channels, on LinkedIn, subscribe to our YouTube, and you will get everything that is from the workshop today via an email from us. And we thank you again for joining from whichever part of the world you are. And we will see you. Yes, go ahead, Nicholas.
Sorry,
yes, any
just
final
one
words?
quick thing before you sign off. So
Yes.
I'm going to push these changes onto GitHub.
Yes.
So I'll just commit it and then push. Once these are pushed, you're able to go back to my GitHub repo and get any updated changes that I have made. So you'll need to make sure, and if you want to get it, just go ahead and fork the repo again. So this will be updated with the tutorial example I just created right here. Okay, and that's it.
Awesome. Thanks so much, Nicholas. I mean, he really gave us a lot more additional resources than we originally started with. So thank you very much. I have packed all of that into an email that you all will get once the recording has been uploaded. So anything else, Leslie Ann, as well? Really want to thank you as well for supporting this session. And thank you all for joining us. And we will see you all in the next one. Take care and have a good weekend.
Bye.